In this video, we will be hooking up the Nokia 5110 LCD screen and displaying bacon. As a prerequisite, you must have this board already built. It's the ATmega 328 board that we've constructed earlier, and you gotta have the screen and you gotta have some wires. Let's go ahead and get started. But before we go ahead and wire up the screen, we have to know how the screen works so that if the robots ever invade and take over the world, we know how to stop them. So imagine this piece of graph paper. That's what it is. It's called graph paper. Imagine this piece of graph paper is a screen, and each little box is what we call a pixel. And screens are basically made up of pixels, and each pixel is like a light. It's a little dot on the screen. Like if you stare at your screen really close up, you can see it's made up of little dots. And to display an image, each little dot is the same color as a little dot you could make. Like if you divided up a whole picture into a whole bunch of dots, then each pixel would show the color of the dot that would be on the image. And then there's black and white screens. They're not as cool, but that's what we have today. Well, more like green and black, because like green background and then black lettering and stuff. But you get the idea. So I want to display bacon on the screen, and we have to figure out, well, how does it actually work? How does it display bacon? How do you tell it to display bacon? And what happens for the screen is it gets a rectangle. It gets a block, if you will, of like a block that's 6 pixels wide and 8 tall. And this block is for one letter. And so you could put like I. And the boxes that I have squiggles in are like the ones that are being lit. Now, you could say, well, why is it 6 by 8? You could make it 3 by 7. I mean, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. You could put it in that box. Well, what is going on is this 6 by 8 box is going to be for all letters. Long letters, fat letters, big letters like capital M. Like, try doing that in something like this. There's capital M. And so this box fits, all letters fit inside of a 6 by 8 box. Now, you might have noticed that it's empty here and here. Well, that is for spacing. Like when you have letters and numbers, you don't want them touching each other. They're shy and they don't want to be touched. And it's easier to read when they're not all scrunched together. So I went ahead and I wrote out bacon. So as you can see, I have, for every place it's filled in, down below, I've written it out in ones and zeros instead of ink or no ink. And so where there's black, there's 1. Where there's not black stuff, it's 0. And so the first column would be 7 ones, so 7 ones, and then a 0. And then for the next one over, it would be 1, 0, 0, 1, 0, 0, 1, 0. And you can see it's 1, 0, 0, 1, 0, 0, 1, 0. So basically that just goes on and on. And so basically the microprocessor says, alright, display that number, it gives it that number, and so it puts that there. And then it says put that number out there, put that list of binary information, and it turns it into that. And so we have to do that all the way across till we get to the exclamation mark. And that is what's sent. And so we can send anything. Like it doesn't have to be a letter. It doesn't say display A. It says display these dots. So we're going to go ahead and we're going to practice figuring out what it would be for displaying something. So I'm going to draw a smiley face. And so there's the smiley face. So what it would send is, for all the blank spots, it would send zeros, and then for the spots that are black, that are filled in, it would send a 1. So for this first row, it would be 0, 0, 0, 0, 1, because see, there's like so, and then all the rest would be zeros. So that's like the first thing it sends. So it sends that, and the screen says, oh, you want this. And then we send the next one. And so the next one would be like, I'll space this out a little bit so it's easier to read. Do 0, 1, 1, 0, 0, 1, 0, 0. So like here's the 2, and then there's, like you see that. And then this next one, 0, 0, 0, 0, 1, 0, 0. So that corresponds with that right over there. And then you got 0, 1, 1, 0, 0, 1, 0, 0. And just 2 more. We got 0, 0, 0, 0, 1, 0, 0, 0. And for the last one, since it's all 0, like it's all blank so that it doesn't run into the next thing that's over here, it's all zeros. 0, 0, 0, whoops, 0, 0, 0, 0, 0. So it sends this, then it sends the next one, next one, next one, next one, and next one. And then on the screen shows that. And so yeah. Alright, so now we're going to build the circuit. So I hope you still have your ATmega 328 board. And the first step is, attach another breadboard to it, and we're going to put power on the buses. And what I mean by that is like, these are the buses, and see this breadboard, it's only like linked to this other breadboard, but that doesn't mean like that power and stuff are getting to it. So I'm going to start with putting a jumper wire, nice little wire, and this could, it doesn't matter what color the wire is, but when you see black on here, that's the 0 volt bus. That's like connecting to the negative side of the battery. So we need to connect this wire, or we need to connect this bus to that black wire. The next thing we're going to do is the same thing, kind of, for the positive volts bus. And that right there is what you want to do. And we don't have to connect it all the way to the other side because we're actually not going to use it. So if you want to connect like that from there all the way over to there, then yeah, that's cool, but you don't have to. Next thing I'm going to do is when you look on the back of here, it has, man, camera does not like that, but there are nice little, there are numbers, and then there's some abbreviations, and there's VCC, that's like where power needs to get, and there's ground, that's like the negative side of the battery, and there's some other stuff. And so you can see what's connected over here is connected all the way over here. So the writing's over here, pins are over here, but we'll get there. So the first pin, like that one right there, has to get connected to power, and that's why we have that guy right there. The next two have to be connected to ground. So we will go ahead and put in 2 little wires. Whoop, that bent a little bit. There we go. So you've got power, and you got ground, and another ground. So 5 volts, 0 volts, 0 volts. And then the next part, real easy, and it looks pretty cool. I'm going to connect pin 9, that's the bottom one right there. Pin 9 goes to the next one. Pin 10 goes to the next one up. Pin 11 gets hooked up right like so. And pin 12 just like that. So, and the only thing left is to insert the screen. So you want to have the pins on the left side, and you want to connect it all the way at the bottom. So like not up one, you want it at the bottom. Then you insert it in. So I'm kind of nice. I've already written up all the codes, so you don't have to like memorize the binary and know what the ASCII value for B is or A is. You can put any letters, you can type anything into the code, into the function that's already been written up, and it'll work just fine. You can replace bacon with something else like steak or, I don't know, chocolate or coffee. You can do stuff like that. You can make it say other stuff. But yeah, you just make sure to plug your board in, make sure that it's on, and then download it. And behold the bacon.